This is video number 4 for sections 1.3 and 1.4, special pairs of lines. We'll conclude our discussion of slope by looking at a couple of special cases. The first one involves what are called parallel lines. Parallel lines just means two lines that never cross. Kind of like the edges of railroad tracks. They just go on and on forever. They're never going to meet. We call those parallel lines. Well, what can we say about the slopes of these two lines? Well, clearly, these lines have the same steepness. They have to, because if one of them was steeper than the other one, they would eventually cross. Well, if they have the same steepness, then of course that means they have the same slope. What we say for parallel lines is the slopes are the same. And that's something you want to take away from this lesson. Parallel lines always have the same slope. Well, the second special situation is the situation of perpendicular lines. Now this is a little bit more complicated. Perpendicular lines are two lines that cross, but in a special way. They don't just meet any old way. They meet in what's called a right angle. In other words, they make a nice square corner here, a 90-degree angle, a right angle. Well, it turns out that when you have perpendicular lines, their slopes are also related in a special way. Are the slopes the same? Definitely not. I mean, just from this picture, you can tell that for example, this line is going up, which means it has a positive slope. This line is going down, which means it has a negative slope. One thing for sure is the slopes have opposite signs. One's going to be positive and one's going to be negative. What about the steepness? Well, even from the picture, I think you can tell that one of these lines is kind of flat and the other one is kind of steep. Let me try to draw in some rise-run triangle pictures for you. So I know my pictures are only a rough sketch here, but can you tell from what I've drawn that the run was really long here and the rise was short? And now that's been reversed over here. Now the run is short and the rise is really long. What's happened is the rise and the run have switched places. Well, that means the slope fraction is going to be turned upside down. For example, let's put all this together. Let's say that we knew that this first line down here had a slope of 3/7. That looks reasonable from the picture, a rise of 3 and a run of 7. Well, that means without doing any work, if I know that this other line is perpendicular, I already know what the slope is. It's definitely going to have the other sign. This guy was positive, so this guy's going to be negative, and the fraction is going to be flipped upside down. So instead of having 3/7, it'll be 7/3. Positive 3/7 for this guy, negative 7/3 for the other guy. How do we say that? Well, what we say is the slopes are opposite reciprocals. Opposite meaning we change the sign, and reciprocal is the fancy name for turning a fraction upside down. So that's what you want to learn. Perpendicular lines have slopes that are opposite reciprocals. Well, let's finish with just a simple example. This problem says, go ahead and figure out whether these two lines given, I've given you two lines here, figure out, are they parallel? Are they perpendicular? Or is there nothing special about them? They don't have any special connection there. Well, this turns out to be a very, very simple task as long as you understand the information we went through. It's just all about looking at the slopes. I made this example particularly nice because both of these equations are in the good format, right? They're both in slope-intercept form, the y equals mx plus b format. If they weren't, I could always put them in the good format first. Let's jot down the two slopes. Looks like the slope of this top guy is 3, the number in front of the x, and then it looks like for the second line it is negative 1/3. Well, are these slopes the same? Obviously not. One of them is a whole number, the other one's a fraction. They're not the same thing at all. That means these lines are definitely not parallel. Are they perpendicular? Well, there's two things I have to check. I have to check the signs, and I have to check that reciprocation issue. Let's see. Well, this guy's positive and this guy's negative, so that's good. That fits with the opposite. What about the flipping upside down part? This guy looks kind of funny because it's just a whole number. Well, as we said earlier, you can always take your whole number slopes and write them as a fraction if you wanted to temporarily by putting a 1 underneath it. And I think that's helpful here because you can see now that, yeah, if I flip 3 over 1 upside down, I'm going to get 1 over 3. That means these two slopes are opposite reciprocals, which means the answer to the question is these two lines have got to be perpendicular. Remember, if neither of those two special relationships had worked out, then I would have just said neither. Make sure to work hard at learning and understanding how slope works. We'll be using slope a lot in upcoming lessons.